let's have a look. I started reading through this one. So it says a manila rope used for rappelling down a cliff can safely support a weight, capital W, in pounds. So here's our weight, provided that the weight, W, is less than or equal to 1,480 d squared, where d is the diameter in inches of the rope. Listen up. Graph the inequality and interpret the solution. So it's already graphed for us, first of all. So we don't need to worry about the graphing. But we do need to talk about what's happening here. So this is a W is less than or equal to. So you can see there's a solid line here. The shading here is not super obvious, but we can figure that out because it says less than or equal to. So where should we shade on this? Above or below? If it's less than or equal to. Shade below. All right, so I'm just going to shade in below this, darken that up a little bit because these are all the answers down here. There's a little box there. That's why I didn't shade that in. It is shaded in behind it, though. So this is our set of solutions right here underneath the parabola. And does anybody know what we're actually talking about here? Like, what's going on? It sets up this scenario. It says it's a type of rope, I guess, a manila rope. So it's used for rappelling down a cliff, and it can safely support a weight in pounds, provided that W is less than or equal to 1,480 d squared, where d is the diameter of the rope in inches. What does that mean? Take a look at the graph here. Here's our diameter. Here's the weight. The larger the diameter of the rope, what happens to the weight? It increases. So basically what we're saying is, if you go rock climbing or if you rappel down something, the bigger rope you have, the more weight that rope will hold. That makes sense, right? Yeah, the safer you're going to be. A smaller rope will have a lower weight limit. Usually there's this thing called a weight limit, right? There's a limit to how much weight that rope can support safely. If you go over that limit, that rope is no longer safe to use and it might snap, which is not a good thing if you're rappelling down something. So that's what we're talking about here, which is why we're shading underneath it. These are all the safe operating weights for the different diameters of rope. Everything underneath here is safe to use with the particular diameter of the rope because it's not likely to break the rope. Everything up here would be over the weight limit for the particular diameter, meaning you're no longer safe and it might snap and you might fall. So that's the scenario. So if you have a rope with a 1-inch diameter, that looks to be about a weight limit of 1,500 pounds, which is actually kind of a lot. A 1-inch diameter, so across, right? So a circle that's 1 inch across can hold 1,500 pounds. That's pretty heavy duty, I think. So right here it says graph. It says graph y equals 1,480 d squared for non-negative values. Why is it only showing positive values down to 0 and not negative values over here? Negative diameter is not a thing. Negative weight's not a thing. So it doesn't make sense to show that. 0 is the lowest you can get for both diameter and weight. And it just goes up from there. So yeah, negative diameter doesn't make sense. Neither, even though it's a parabola, we don't need the entire parabola. We just need the right half of it or the right part of it. Because positive values for diameter and weight are the only things that make sense. All right, so it says non-negative values. Because the inequality symbol is less than or equal to, you're going to make the parabola solid and you're going to shade underneath it. And then it says test a point inside the parabola. If you test a point inside the parabola, any point inside that parabola is going to be over the weight limit, no matter what. Any test point outside the parabola is going to be within the, regulations or whatever. It's going to be within the operating limits of the rope, which means it'll be safe to use. So that's what we're talking about here. We don't need to do any math. We're discussing what this is, because every single one of these problems that we're dealing with, or every single mathematical inequality that we're dealing with, could be used in a real life scenario. This is one example of that. All right. Moving on to the, I think, a little bit more challenging part of this lesson, because I think the graphing part yesterday wasn't too bad. It was mostly what you did in Algebra 1, except we applied it to parabolas. Like, that's about it. All right. So, yeah, go for it. Take a pass. I'm outside. Cool. All right. So now we're going to be solving quadratic inequalities instead of graphing them. So you will notice that these will not include x's and y's. These are only going to include x values, which means we're only going to be having x values. We're not also going to have y values. So here we go. This is going to look really similar, by the way, to the very first page that we put down yesterday. It's going to look super similar to this stuff here. But we're not going to have to write up anything about dashed or solid or shaded or anything like that because we're not going to be graphing. Those words only apply to graphs. So instead of having a y is less than or greater than or less than or equal to or greater than or equal to, when you solve for x, what goes on the opposite side of the equation, or in this case, inequality? 0. Yeah. So instead of y is less than, we're going to say 0 is less than ax squared plus bx plus c. Or we're going to have 0 is greater than ax squared plus bx plus c. Or, and actually, you know what? Go ahead and do me a favor and erase that real quick. I actually don't want the 0 on that side. I want the 0 on the other side. I'll tell you why in a minute, but yeah. Actually, trying to think here. I'm gonna decide if I want to do this one way or the other. Yeah, let's have it written like this. So have the 0 on the right side. So I'm gonna switch this around. So we're gonna have ax squared plus bx plus c is greater than 0. We'll have x squared plus bx plus c is less than 0. And then we'll have the greater than or equal to, or the less than or equal to as well. All right. So ax squared plus bx plus c is greater than or equal to 0. And we're going to have ax squared plus bx plus c is greater than or less than or equal to 0. Okay, that's what we're dealing with there. So moving on, we are going to be working with this first inequality here, and we're going to solve it for x. And it's going to work a lot like what we did with our equations. I'm just going to double check something very quickly here. All right. So the way that your book actually tells you to solve this, I'm not a fan of. And I actually deleted some things from these notes because I'm not a huge fan of how it showed how to do it. I think there's a more efficient way to do it and a simpler way to do it. And I'm going to teach you that way as opposed to the way that it wanted you to do it. So I'm just going to show you real quick. You'll notice I deleted the thing that said test points and I deleted the thing that said graphing at the bottom because I think there's an easier way to do it than doing that. We are definitely going to do this part in terms of the algebra. We're going to solve the quadratic like we normally would. But then we're going to go ahead and talk about the entire function as a whole. So this x squared minus 3x minus 4. Let's talk about the graph of that real quick. We're not actually going to graph it specifically or in detail, but we are going to do a quick sketch of that graph. So if we were to sketch this graph, let's just do that off to the right real quick. This does not need to be particularly accurate. But it does need to be accurate to a degree. So what direction would this parabola be facing? Up, right? And we definitely have ourselves a y-intercept at -4. And thinking here, our vertex is going to be over with an x value in the negative. So it's going to look something like that-ish, okay? Everybody okay with that so far? Like this graph would be roughly something that looks like that. And if you want to graph this on your graphing calculator to see what it looks like, feel free. But what we're talking about here, all the values of x that end up being less than 0 for the y-axis, right? Because this 0 talks about the value of the y. I mean, if we're talking about y value, right? If we were to write this as an expression or an inequality in terms of y as opposed to in terms of 0, it would be values of x that are less than the values of y, essentially. Everybody okay with that? Like if I were to write x squared minus 3x minus 4 is less than y, the values of x would be less than the values of y. And the values of x that are less than the values of y here, we're talking about the part that's underneath the x-axis. Is that okay? Less than would be underneath the x-axis because we're talking about values of x that are underneath the values of 0 on the y-axis. So everything underneath the x-axis is what we're talking about. So we can see that here, right? It would be between those 2 points underneath. So the values of x here that are underneath the that give us y values that are less than 0 are between this point and that point. Everybody okay with that? All we need to do is figure out what those numbers are. So let's go ahead and write our equation like we normally would, solve it for x, and then we'll deal with that in terms of what we're actually looking at on our graph. The whole test point idea is a little bit too like theoretical for me. I'd rather be able to see what's going on. So let's write x squared minus 3x minus 4, and then is actually, you know what? I think we can keep this as an inequality. Let's just keep this as less than 0. Now, if you were to solve this, would you prefer to try to see if this would factor, or would you just rather use the quadratic formula? See if it factors? I think factoring generally would be quicker if you can factor, so I would agree with that. Are there 2 numbers that would multiply to -4 and add to -3? What's that? 1 and 4. One of them needs to be negative, and it has to add to -3, so -4. Good. So this is going to factor to x plus 1 times x minus 4, and then we're going to have less than 0. So here we go. Set each of these, not equal to, but set each of those less than 0. So this would be x plus 1 is less than 0, and x minus 4 is less than 0. And then to solve these, you would subtract 1 here, and you get x is less than -1. And you would have x is greater than, not greater than, less than, sorry, x is less than -4. What's that? Yeah, 4, yeah, less than 4, sorry. Less than -1 and less than 4. So the issue that we run into here, though, is that both of those things are kind of the same, aren't they? There's like some overlap happening here. Because if it's less than 4, if it's less than 4, it's also less than -1. If it's less than -1, it's less than -4, right? So I am, let's see, I'm forgetting to do something, and I'm trying to remember what that thing is. Hang on just a second. So, because we know that the answer is going to be between those, right? So what ends up being, and I'm trying to remember exactly why. I apologize here for a second. I'm just trying to get my thinking straight. So let's see. This one here, tell you what. Let's do the equation instead. Just change your inequalities to equals for me. Change your inequalities to equals for a second. I should have done that the first time. Because what we can do is we can end up using the graph to figure out the answer to this. So when we take a look here, what we're figuring out here are the x-intercepts, right? When you figure out an equals, it's figuring out where the graph crosses the x-axis. So over here, this is going to be the point for one of them, and that'll be the point for the other. So this here's the point, x is equal to -1. So I was a little bit off with my estimate for my graph, which is fine. It doesn't really matter. But this would be the point -1, 0, and this would be the point 4, 0, if we're looking at the graph. And we're looking for all the values where it's going to be, where 0 is going to be greater than the value of x, which is going to be everything under here. So technically speaking, we're talking about all the values of x that are greater than -1 and all the values of x that are less than 4. Because it's in between those two. All the values for which y is less than 0, which is what we're talking about here. If it was greater than, we'd be talking about everything that's greater than, above the x-axis. But here, everything's less than the x-axis. And so it's all the points in between on this point of the parabola, in between -1 and +4. So what we can write is x is greater than -1. We can also write x is less than 4. Because all the values for which the parabola is less than 0 underneath the x-axis is going to be in between those 2 points. Okay. A little bit weird. I think I might actually have this. Well, I think we're okay. Let's take a look at the next one. So there we go. Yeah, we're good. So this one in between the two. And if you graph it, by the way, feel free to graph this. Everything that you see here should match up, except this graph will be it'll be slid over a little bit. It would be more like here and here. But the sketch isn't super relevant as long as you get an idea about what it looks like. So the fact of the matter here is that this is a both and, right? It has to be between this and this. It's not an either or. It has to be and because it's in between two things. So you could write it like this. The other way to write this is when you have an inequality that is a compound inequality, you could write it like this. You could say, you could flip this one around and say that -1 is less than. If you flip the whole thing around, then the arrow is still pointing towards the -1, x, and then is less than 4. You could write it like this because you're saying that x is in between -1 and +4. It's in between those two values. It doesn't include those two values, but it is in between those two values. Now, the other one's going to work a little bit differently because the other one says greater than or equal to. So it's going to be a little bit different in terms of how this one works. And then it'll be a little bit different in terms of how we write the answer. Either one of these answers, though, is perfectly fine. If you write them separately, please use the word and in between the two. Because it has to be both greater than -1 and less than 4 at the same time. They're basically like facing each other in between the parabola. We're going to end up doing one more example after this one as well, just to make sure we're kind of understanding what's going on. And I'm going to show you another way to deal with this because I want to try to keep things consistent for you as you're working through problems like this, because these can be a little bit tricky. So we're going to solve this one. We're essentially going to use the equal sign again to solve it, but then we're going to talk about what it means. So once again, let's get like just a very quick sketch over here. We have an a value of 3, so it's positive. We have a y-intercept at -5. This one's going to be a bit narrower. So again, it doesn't really need to be super accurate. But this one will look, I don't know, maybe about like that. Doesn't need to be perfect. But it will face up. It will be kind of narrow. And these are the values that we're looking at. Now, this time, we're talking about greater than or equal to. So this time we are talking about not below the x-axis, we're talking about above the x-axis. So we're talking about all the values from here up, and we're talking about all the values from here up. So instead of in between the two, we're talking about outside the two, because it's going to be less than this number or less than this number. And that word or is going to be important as we solve this, because it's not going to be an and, because they're not facing towards each other. This time they're going to be facing away from each other. And when we solve that, we'll be able to see what's going on. Any questions on that before we continue? Because a greater than would be above the x-axis. A less than, like this first one, is going to be below the x-axis. So the points where y is below the x-axis are between those two values of x on the x-axis. The points where we go above the x-axis here are going to be getting smaller on the x-axis as this goes up, and it'll be getting larger on the x-axis as it goes up on this side. It's kind of like back in unit 2, real quick, just a second. Kind of like back in unit 2 when we were talking about increasing and decreasing along the x-axis when we were talking about parabolas. So let me see if I can find where that was. Was that unit 1 or was that unit 2? That must have been unit 1. Let's see. Or was it unit? No, that was unit 2. All right. Here it is. So it's kind of like this right here. Kind of like what we were talking about in unit 2, where you're trying to figure out the values of x, where they were decreasing and where they were increasing. So if the parabola is facing up, x is decreasing. Oops. No, don't do that. Okay, it's bad. X is decreasing to the left of the x value of the vertex, because it's coming down from right to left. As it hits the vertex, it's going to increase to the right of the vertex, the x value of that vertex. And this is the main thing that we need to focus on today, is if it's facing up, because we are going to guarantee that all of our parabolas today are going to be facing up. We're going to make sure that we have positive a values. And we can guarantee that by just doing a little bit of algebra, and I'll show you with our very last example that we do. But this is the idea that we're talking about. If you have values of x where y is greater than 0, values of x where y is greater than 0, that has to be above the x-axis. So let's go ahead and solve this using our quadratics, and then we'll go from there. So this one here, to me, doesn't necessarily look like well, can we factor that? Let's see, negative 15 and adding to negative 1. No, that's not going to work for factoring. So let's go ahead and use our quadratic formula. And we can use equals on this to do this. So we're going to say x equals. The opposite of b would be positive 1 plus or minus the square root of b squared, negative 1 squared, which would just be positive 1. If you want to write 1 instead of negative 1 squared, that's fine. Minus 4 times a is 3 times c is negative 5, all over 2 times a, which is 6. So under the square root, let's see, that's positive 1. And this turns into positive 60 over here. So we're going to get 61 under the square root. So that'll be x equals 1 plus or minus the square root of 61 over 6. So those are the x-intercepts. That's whatever this number is and whatever that number is. Now we need to figure out which of these is the positive one and which one is the negative one. That's going to be useful because we do have to write some inequalities for our answer. So let's go ahead and do that real quick. X is equal to 1 plus the square root of 61 over 6. That'll be the positive one, right? because those are both positive numbers on the numerator. So this will be our positive one. And then the negative one's over here. X is less than, or sorry, X equals 1 minus the square root of 61 over 6. The square root of 61 is definitely more than 1, so if we subtract that, the numerator is negative, which makes the whole thing negative. Now we have to figure out what symbols to use here. So we're either going to use greater than or equal to or less than or equal to for these. So for the positive one, that is this point here. Are the values of y that are greater than 0, are they greater than or equal to or less than or equal to the values of x here? They're greater than or equal to because they're going to the right. Does everybody see that? As we go up from the x-intercept, as we go up, the values of y increase, but so do the values of x. The values of x are increasing at the same time as the values of y increase. So for the positive value here, we're going to write x is greater than or equal to 1 plus the square root of 61 over 6. Because as the values of y increase, so do the values of x. Now from the x-intercept that is negative, as the values of y increase, as they go up, what direction is x going? Left, which would be negative, right? Which would be less than or equal to. So as these ones increase on this side, x is getting smaller. As the values of y increase on this side, x is getting larger. So greater than or equal to, less than or equal to. So this is going to say x is less than or equal to 1 minus the square root of 61 over 6. Now, if they're going in opposite directions, which these are, our values of x are going in opposite directions as the values of y increase. That's what we're talking about. Which means those two things can't really be an and, because they're not in between. It's not a boundary between this point and that point and going towards each other. It's this point and that point going away from each other. So we're going to use the word or. It's either this or this. It's not both happening at the same time. If the values of x are pointing towards each other, both of those things can be true at the same time. If the values of x are going away from each other, it has to be this one or it has to be this one. They're not necessarily happening simultaneously. So there's that. That's our or value. All right. Now we use a lot of room for that, so I'm going to try to find some space. We're actually going to go back to the third page real quick, and I'm going to give you one more example because I want to make sure, well, first of all, that we know what we're doing here. And secondly, sometimes your value of a will not start as a positive. And if it doesn't, I want to show you what's going on with that. All right. So I'm just going to pick one from your book. And let's see. Let's look at... Ooh, this is a good one. Because this one's a little bit more challenging. Not that the first two weren't necessarily challenging, but let's go back here and we'll just write on this page, just write down here, we'll say example, add one more in here. This is going to be negative 1/2 x squared plus 4x is less than or equal to 1. So first thing I want to let you know is on a problem like this, we are not going to deal with fractions or negative numbers for a values. And because this is an inequality, which is very similar to an equation, we can manipulate this into not having those things. So let's say I wanted an a value of positive 1. What would I have to multiply by? Negative 2 over 1, right? Or just negative 2. So the idea here is we don't necessarily, to keep things consistent in terms of our little sketches that we did on the back, let's not deal with negative values of a. Let's not deal with fractions for a either. So whole numbers are great. Positive whole numbers are even better. So let's go ahead and multiply both sides by 2. Sorry, negative 2. Multiply by negative 2 on both sides. Because that will get rid of our negative fraction over here, and it will give us x squared. Negative 2 times negative 1/2 is positive 1, right? So that'll be x squared. Negative 2 times 4 is negative 8, so minus 8x. And negative 2 times 1 is negative 2. However, if and when, this is something that you learned in Algebra 1, it's probably been a while since you've done it. If you multiply or divide both sides by a negative number on an inequality, you have to flip the sign. So now we're dealing with greater than or equal to. So when multiplied, or divided by a negative, flip the inequality sign. So when multiplied or divided by a negative, flip the inequality sign around. You have to do that if it's a multiply or divide by a negative. So one last thing we need to do before we can start working through this, which is to do what? Add 2. Yeah, we got to get it equal to 0. If we're solving, it's got to be equal to 0. So let's add 2 to both sides, and that will give us x squared minus 8x plus 2 is greater than or equal to 0. So once again, we're looking for values of y that are above the x-axis, and we have to figure out the corresponding x values for those values of y. So, for example, quick sketch here. We're going to go ahead and get a, let's see, regular looking parabola. This will be, I don't know, something like this. I mean, it doesn't, ooh, this will be interesting. Because our, it'll be, I don't know, maybe about like that. Could be interesting. We'll see. So our x-intercepts, wherever they happen to be, one of them is going to be there and there. Again, it doesn't need to be an accurate representation necessarily. We just need to know where things are happening and what's happening. So as we increase, because we're going greater than or equal to, as we increase on the y-axis, the values of x here are also increasing. So whatever our positive is, if there's a positive or a negative, or if they're both positive or both negative, you're welcome to use, I should probably grab a graphing calculator just to show you what's going on. Because I haven't done that yet with these problems. So I'm gonna go back here. Let's see, x squared. And you can get this on Desmos as well if you want to, if you're at home, minus 8x plus 2. And if we graph that, yeah, it looks roughly, you know, generically something like that. Not perfect, but it's okay. So every value of x that creates a positive value of y over here is going to be increasing that way. Every value of x that creates a positive y over here will be decreasing that way. Does that make sense in terms of what's going on with those? Okay. As this one's getting bigger, x is getting bigger that way. As y is getting bigger here, x is getting smaller that way. So whatever we get for our, by the way, both of these are going to be positive. Both the x-intercepts are going to be positive based on that. So the smaller of the two values that we get for x is going to have a less than or equal symbol next to it. The larger of our two values of x will have a greater than or equal to symbol next to it. So let's figure this out. That's not going to factor, is it? Doesn't look like it. No. If we wanted to, we could complete the square, but let's just use the quadratic formula. So x is going to equal the opposite of b, so that'll be 8 plus or minus the square root of 8 squared is 64 minus 4. A is 1, so I don't need to worry about multiplying by that. And then c is 2. So over 2 times a, 2 times 1 is 2. Let's see, 64 minus 8 would be 56. So inside the root, we get square root of 56. So x is equal to 8 plus or minus the square root of 56 over 2. Does 56 have any perfect square factors? Because we're going, what's that? 8 times 7, sure. 8's not a perfect square, though. 8 has a perfect square factor, though, 4. So 56 divided by 4 is 56 divided by 2 is 28. 28 divided by 2 is 14. Yes. So 14. So that'll be 2 root 14, I think. So x equals 8 plus or minus 2 root 14 over 2. And 8 and 2 are both divisible by 2. So this would be x equals 4 plus or minus the square root of 14. Because they both divide by 2. Both 8 and 2 divide by 2. All right, now I'm going to double check my teacher edition, make sure that we end up with the right things here, because, you've seen me make mistakes before. All right. 34. I think we'll be all right. So, yeah. So if we take a look here, I think he is too, as soon as he gets back. Which one of these will be larger, the plus or the minus version? The plus version is going to be larger, yeah. So 4 plus, so we're going to have x, and then 4 plus the square root of 14. The larger one, if we look here, are the x's getting larger or smaller? Larger, so that's greater than or equal to. Or, this one's going to be an or because we're going opposite directions. The other one will be x is less than or equal to 4 minus the square root of 14. And those will be our two answers right there. And I'm just going to double check because the back of the book actually gives decimals for these. So I want to see that my decimals actually match with theirs. So that would be on 34. Yep, that looks good. And then 4 minus the square root of this 14 would be about, yeah, we're good. So that's what we got there. Any questions? I know this is not the easiest thing we've ever done. However, if you create a quick sketch, here's the thing. If they go opposite directions, it will be or. Meaning the larger one will be greater than, the smaller one will be less than. If they are going, if it is less than or equal to, they will be going towards each other underneath. And this nice thing is that because we're making sure that A is positive every time, the less than will be the part of the parabola underneath the x-axis, which means they'll be facing towards each other if it's less than, which would be an and situation. Or you can write it like this as a compound inequality. If it's the other way around, if it's greater than or equal to, it's going to be an or situation with the larger value of x getting larger and the smaller value of x getting smaller. Larger value of x on this one gets smaller, while the smaller value gets larger. Because it'd be in between because they're beneath. Or if it's above, they're going opposite directions. So I will definitely take questions on this for the rest of class today because you have 2 assignments that you can be working on. You got 3, 5, and 3, 6 now. So let's see, stop.